Okay, today we're going to look at different quadratics and the different formats you will see these quadratics in. So, first one, this is called standard form, number 1. It's the thing that you've been seeing that we've been factoring the last couple days. It's in a x squared plus or minus some x plus or minus a number. With these, usually we go to the calculator or we try to factor them to get our information. Alright? Things that we need to look for: the vertex or the bottom or the top of the U. Orientation is up or down. Shape is narrow, normal, wide, like we were doing before. And in fact, we could already do that. It kind of follows the same rules as the absolute value function. So, orientation. If there's if it's positive in the front of the x squared, it's going to be up. It opens up, I should say. Okay, the shape, this is a normal curve, because again, the coefficient in front is 1, so that will make it normal. Alright, now we're going to go to our calculator to get the rest of the information. So get your calculators out and pause the video if you don't have it out yet, and then we will begin. You should go to your y equals and type the first problem in your y1, and we're going to type 0 in for y2. The reason why is we want to find the x-intercepts, which are your zeros. We talked about that in the last lesson. So once you do that, go to graph and you should get a parabola that looks like that. Again, we're looking for the vertex, we're looking for the zeros, we're looking for the y-intercept also, but that's actually really easy to do because then you just plug x is equal to 0 and get the value. So here's how you find the minimum or maximum. This is called a minimum because it's the lowest point on your parabola. So here's what we do. We hit second, trace, and if you look at all your options here, we have a thing called minimum. So let's click on that. I want to be to the left of that. It says left bound. That means be to the left of the point that we're looking for, and hit enter somewhere. I'll hit enter over here. Now it says right bound. It's trying to find like a range to look for the answer in. So I'm going to hit enter to the right of the point. Now I'm going to go to where I think the point is and make an educated guess and hit enter. And notice my calculator gives me 0.9999993 and -2. I do not want you giving me 0.9999993. I want that's just the calculator's way of telling you that that is 1. Okay? If it's something that's really close to a number like that, it's 1. It's just the calculator has some error sometimes when they calculate it, and yours might give you 1 when you do it. So, alright, so we have our vertex. So let's write that down. So I have my vertex of 1, -2, and I'm going to plot that on here, 1, -2. Now let's find our y-intercept. That's when x is equal to 0. Oh, actually, you know what? Let's do the equation of the axis of symmetry. The axis of symmetry is, once you draw your U, or your parabola, it's the axis that it would fold over. They're always going to be vertical lines, and it actually always goes through the vertex. So once you get the vertex, you should automatically write, we have a vertical line going through that vertex at 1. It comes right from where the vertex was. This always comes from there. Okay? So that is my equation of symmetry. My y-intercept, I plug in 0 for x. So y is equal to 0 minus 2 times 0 minus 1. Y is equal to -1. So the y-intercept is 0, -1. So there is a point there. And you should know that parabolas are always symmetric over the axis. So that means that if I moved 1 to the left and 1 up, I have to move 1 to the right and 1 up to get my other point. Okay? Now let's find our x-intercept. So let's go back to our calculator. And once you're on your calculator, let's go to second trace again. And we're going to do that second trace 5, which is our intersection points. Okay, so we hit enter. Oh, we don't want to know the derivative. You guys aren't there yet. Okay. Intersection. I want to know the intersection where it hits the x-axis. So right around here. I'm going to hit enter, 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 and I get -0.414. Round to 3 decimals if it's a rounding one. If I want exact, you're going to have to use, this tells you that you have to use quadratic formula to solve this if you wanted those values exactly. But for now, we just want to know what they are. So I get -0.414, so I'm going to write that one down. So I have negative 0.414, comma 0. And now I just need to get the other one by going back to the calculator. Okay, so second trace, 5. And now I'm going to hit up just to get onto this line and move. Well, just move over to the other place where you see the 0 possibly. Hit enter 3 times. And my other 0 is 2.414. So now I have that value as well. So I have 2.414 right here. Move this over here actually. So this is y equals negative 1, 2.414. And then now we can plot those points too. And I want accurate graphs, guys, so do not just plot these 5 points and be done with it. Negative 0.414 is about there. 2.414 is about there. And again, it's symmetrical. But I want better points than that, because you can make the parabola, but give me more so that they are you have enough points to plot. So here's how you get the final last pieces of your graph. Go back to your graph and go to the table and look at it. So I do second table, and here I am. I knew that the vertex is at 1, negative 2. I have 0, negative 1, and 2, negative 1. So I'm going to go backwards. Negative 1, 2, and negative 2, 7 are other points. So negative 1, 2, and negative 2, 7 are my other points. So negative 1, 2, there's a point here, and negative 2, 7. Now, the other thing to do is you can go the other way and do that too. They're symmetrical. So at negative 1, I am also at 3, 2, and then 4, 7. And then your parabola should look like a U. Do not give me a V. It should be a curve. Okay? And that is our parabola. And that is what I need to see. I need to see exact points on there. Okay, your graph should be accurate. So that is all the information we're going to get. We're going to use our calculator for a lot of this lesson today. The nice thing is this next one is in a form you guys should recognize. This is vertex form. Remember that this was vertex form for absolute value. It is also vertex form for quadratics. Right away, remember it's the opposite of the inside sign, and then it is whatever that outside sign is. So the vertex is negative 3, negative 2. I already have the vertex of my parabola without even looking at a graph. Now, orientation, it's a negative in front, which means that it's going to be oriented by opening down. The shape, 2 is bigger than 1, so it's going to be more narrow. The equation of the axis of symmetry is the x value of your vertex again. Here it is, x equals negative 3. My y-intercept is when x is 0, so for the y-intercept I'm just going to solve this over here. Y is equal to negative 2, 0 plus 3 squared minus 2. And again, you can also look at your table to get this value, but I'm showing you by hand how to do that. So 3 squared is 9, negative 18 minus 2 is negative 20. So that's 0, negative 20. That's a far away, so we won't see that on our graph. And the x-intercepts, let's look at our graph now. Let's look at our graph. Now you can type in your equation just as you see it on the problem. Notice how I didn't foil it out or anything like that. I'm just typing it in as is. So I'm going to hit graph, and I'm going to look at this, and I see that, yep, there's my graph of negative 3, negative 2, but I don't see any x-intercepts up here. That's because there are none. Okay, that is because there are no x-intercepts, which means that there would be no solutions to this problem. No real solutions, I should say. So let's go back to our thing here, and we have none. And now we're going to graph some points. We know we are at negative 3, negative 2. So basically, and we know 0, negative 20 is down there. So I'm going to just look on my table at negative 2, negative 1, negative 4, and negative 5. So I'm going to go back to my calculator and do that. Second table, I want to look when x is negative 4 and negative 5. So at negative 4, it's negative 4. At negative 5, it's negative 10. Those are points on my graph. So I'm going to go to those. And I don't know where my recording went. Oh, I think I'm recording. Okay, so anyway, I think I was recording that. Just ignore that last few seconds. Sorry. We had -4, -4, and -5, -10. If you go the other way, it'll also follow suit. So -2 will go down to -4, and -1 will be at -10. All right, and then you can graph your curve. And that's more narrow than the other one. All right, this third form is called intercept form. The reason why this is also called factored form, because we can get our x-intercepts right from here. Okay, if we set both of these equal to 0, that's when y will be 0. So right away I can put my x-intercepts down here as -4, 0, and -1, 0. Okay. Now again, the other thing you can figure out is the vertex is directly in between these two values. However, we're going to use the calculator for that too. But you should realize that they're directly in between -4 and -1, which would be -2.5, but we'll deal with that in a second. Orientation, this is positive, so it'll be up. Shape will be wide. Alright, so now, and then let's get our y-intercept real fast. We have 0 plus 4, 0 plus 1, times 1/3. So we get 5/3. So we have 0. I'm sorry, that's not 5/3, that's 4/3. So it's 1/3 times 4 times 1. Now we're not adding. So 0, 4/3. So I have that point on here too. 0, 4/3. It's about right there. And let's find the vertex by plugging this into our calculator. This is what it should look like on your calculator. 1/3 in parentheses, x plus 4 in parentheses, x plus 1 in parentheses. When you graph it, it should be a parabola that opens up, that's a little wider, and there we are. That goes through those points that we just plotted. So all we got to do is get the min, which is our vertex, second trace 5. Nope, not true. Second trace, we want the minimum. I'm so used to doing intersections. Alright, we need to be to the left of the point again, so move all the way to the left of it somewhere. This is fine right here. I'm going to move to the right now and hit enter. And then we hit enter in between. And sure enough, we get -2.5 and -0.75, which are also fractions if you want to go the fraction route here. But I'm okay with either or here in this case if you're using the min-max feature. So let's put those down. You know what, let's keep them in fractions actually. So -2.5 is -5/2, and 0.75, -0.75 is -3/4. And then we have the equation of axis of symmetry is x equals -5/2, which is -2.5. So -2.5 and -4/3 is right around there. Okay, and now we just have to get a couple more nicer points. So we're going to look back at our table to get those. Now with the table, you want to find the nice points. There are my zeros. I want to find the next one that's nice. -7,6 is one. And I'm going to go the other way and figure out where the other 6 is, and 2, 6. If I put -7,6 and 2, 6 on my graph, that should be fine. So I'm going to do that. -7 up to 6, and 2, 6. And now I can graph this parabola. Again, it opens wider than the last one that we've been dealing with. And there we are. We have all the information and we have it graphed. So those are the three forms you will see. Intercept, which is also called the factored form. Vertex form, which you get the vertex from it. And then standard form, which you can try to get it into vertex or intercept form from there. Otherwise, you have to use quadratic formula or other means to get your information. Usually the best thing about standard form is it's very easy to get the y-intercept. You just plug zeros in for these two. It's the constant that remains. Alright, so let's go to the next page. Write the quadratic function in standard form. Okay, standard form again is just multiplying it out. So I'm going to do this first and then multiply the two afterwards. So this is like reverse factoring. FOIL it out, x squared minus x, minus 6x, I should say, minus x plus 6, 2 times the quantity x squared minus 7x plus 6. So my final answer will be y equals 2x squared minus 14x plus 12. And now for this one, same thing. We have to go from vertex form to standard form. First things first, let's deal with this. Again, this is 8x minus 1 times itself, not 64x squared minus 1. Or plus 1, whatever you want to do with that. Okay, so let's multiply that out. We get 64x minus 8x is a minus 16x plus 1. There we go. Now we do 1/2 of that, and we then add or subtract the 3/2. So I multiply the 1/2 in everywhere, and I get y is equal to 32x squared. These should be squared, by the way. Minus 8x plus 1/2, and then we have minus 3/2. Well, 1/2 minus 3/2 is a -1. So standard form for this problem is 32x squared minus 8x minus 1. Alright, so those are our answers for 4 and 5. Again, just foiling it, multiplying it out, getting it to standard form, which is what the form is that we usually then go backwards and factor. So, a woodland jumping mouse can hop surprisingly long distances given its small size. A relatively long hop can be modeled by this equation right here, where x and y are measured in feet. How far can a woodland jumping mouse hop, and how high can it hop? This is a straightforward calculator problem. You know what? I want you guys to try doing this on your own. So I would just plug this in, and then think about where the 2 spots are that you have to find on your calculator to answer that question. Okay, and then I will go over that one with you in class. And I hope you guys understand that. And then down here, this again is a nice little chart to tell you the different forms. Vertex is graphing, standard form is just standard form, and an intercept form gives you the x-intercepts. Just some information for you. Okay. I will see you guys later.